Hi everybody and welcome. Today we're going to be talking about bisectors, medians, and altitudes of triangles. So your goal after watching this video will be able to identify and apply your skills to problems with solving triangle questions with, again, bisectors, medians, and altitudes. So we want to be able to solve questions with them and also be able to, again, understand the definitions of these things. So first things first, want to understand some of the background knowledge that we need. So concurrent lines, this is when we have two or more lines that have a common point of intersection. Now the point where they intersect is creatively called the point of concurrency. So again, this is the point of intersection. So again, where multiple lines come together, point of concurrency, and again, concurrent lines when two or more lines intersect at a common intersection or a common point. Next, median. This is a segment whose endpoints are a vertex of a triangle and the midpoint specifically of the opposite side of that triangle. So again, looking at a triangle like this here, we start off at a vertex and it has to also cross at exactly the midpoint of that other segment. So it cuts it exactly in half. And that's what we're looking at right there. All right, so keeping it going here on to our next set of questions. And I want to make sure I'm clicking on the right thing here. Here we go. So the centroid is the point of concurrency for the median of a triangle. And when we're looking at that, the centroid theorem is saying it is, and again, first let's draw these in. Okay, so again, crossing at the midpoint from a vertex. So there's our first median. Our second median, again, crossing at our midpoint here. And then our third median, it'd help if Google didn't kick me out here, but we're doing it. Our third median in blue, again, going over to our midpoint. So again, here is our centroid in blue, and there is a theorem specifically about this. So the centroid of a triangle is located 2/3 of the distance from a vertex to the midpoint of the side opposite the vertex on a median. So our example here, this is just a really fancy way of saying this distance right here is worth 2/3, and this smaller distance on our other side here is only worth 1/3. And gosh, it is kicking me out multiple times here, but that's all right. So again, this part here is worth 2/3, and over here, this part is only worth 1/3. So if we're looking at an example of this, like on the bottom here, I'm having no luck with this today. But if we're looking at an example on the bottom here, we know that this distance in blue is worth 2/3, and then we know that our squiggly line here, that's only worth 1/3. So 2/3 of our whole line, so 2/3 of x, equals 6, so we can solve for that. So again, use a little bit of algebra. We're going to use our reciprocal to multiply in and solve, and we'll be able to see, we'll get x equals 9. 18 over 2 gives us 9 here. So 2/3 equals 6, or the whole line equals 9. So now we know that 1/3 of that whole line, or 3, is going to equal our 2x minus 5, our little squiggly portion here. So a second thing that we're going to be able to go through and solve. So 8 equals 2x, divide both sides by 2, and we'll get x equals 4. So again, we used our knowledge knowing that this equals 2/3 right here. We solved for the whole using that knowledge. We then applied our knowledge to see that this right here is only 3 because it's 1/3, and we could set 3 equal to 2x minus 5 and solve for x. So a classic example here of applying that vocab to being able to solve. When we do that, we're going to be in good shape, again, applying definitions to a more algebraic product, our skill here. All right, to keep it going, altitude. Altitude is a segment from a vertex. So again, one of these points is a vertex to the line containing the opposite side and perpendicular to that line containing the side. Really fancy way of saying we don't care about splitting it in half anymore. We're just trying to draw this straight down so we can get a right angle. So perpendicular means 90 degrees. Second, orthocenter, this is the intersection point of the altitudes. So example number 2, we are told that we have a median, and that median tells us that this here and this here are equal to each other. So we're going to know that 2x plus 24 is equal to 5x minus 30. And we want to know, is this also an altitude? So when it goes down, does it cross at a 90-degree angle? So we want to see when we do 4x plus 18, what does this equal? Does it equal 90? Well, the only way that we're going to know is first solve for x here, plug x in, and if x equals 90, then yes, we're going to see that it's an altitude. If x doesn't equal 90, then no, it won't be an altitude. So that is your job right now. Go through, pause the video, solve for x on the left side here, so move it around algebraically until we get x equals, then take that and plug it back into the angle. And again, if that angle equals 90 degrees, then we'll know that we also have an altitude by definition. All right, so again, another example of applying some vocabulary knowledge to correctly solving. All right, finally, our last one here, a couple quick definitions. So perpendicular lines, a quick reminder, this just means that lines that intersect at a 90-degree angle. And bisector means when we split an angle or a line into equal parts. So a perpendicular bisector, it is a line, segment, or ray that passes through the midpoint of the side of a triangle and additionally is perpendicular to that. So again, start at the midpoint, got to go straight up for it to be perpendicular at a 90-degree angle. And we can do that for all of our sides here. So again, start at a midpoint, and we go straight across here at a 90-degree angle. We can do this one more time. Again, start at about halfway through. We want to go straight up and straight down. And all these are at 90-degree angles. The circumcenter is the point of concurrency of the perpendicular bisectors of a triangle. So a really fancy way of saying that thing right there, that dot where all of those things intersect. That's called the circumcenter. So a lot of vocab and a lot of words for the places where lines cross today. Just important that in our notes we're keeping track of these. We have a good place to access them when it comes time for an assessment to access those notes. So again, make sure we're keeping careful notes from this video. Not a whole lot of questions to solve today, but a whole lot of organization to do to make sure we're not losing track of any of these vocab words. All right, so finishing up our points on perpendicular bisectors is a theorem that relates to this. So any point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. So an example of this, perpendicular bisector, we cut the line exactly in half at a 90-degree angle. And if we do this, it doesn't matter where we are on this line. We could be here, or we could be here, or we could even be here, no matter where we are. This is going to be equal to the other line that's formed if we go to those endpoints. So again, equal lines that form. Same thing here. We know that this is equal to this, and if we were to draw a line from here to here, we would see that this is also equal to this if we drew it perfectly and bisected it perfectly. So again, a fancy theorem, going to be useful in proofs, just saying that it doesn't matter where we are on the purple line, we'll always be just in the middle of C and D. We'll always be able to trace a line to both of those points that is equal on both sides. So again, quite a few vocab words today. Make sure we're keeping track of those, and that's going to wrap it up for our video. So any questions, please make sure we're bringing them to class, that way we can answer them. Make sure we're completing and turning in the remaining example problems that are attached to the notes for this video. So again, log into that form, make sure opening up the notes in that Google Doc and completing any and all the questions there. We went through a few of them, but not all of them in the video today. As always, any questions, feel free to reach out, save them, bring them into class. Thanks for tuning in, everybody, and I'll see you very soon.